Oh,
Ready?
Yep.
Welcome to the O-House repair trainings. We're going to be going through 4 different product lines today, and to give you an insight into how we're going to be running it. Each repair training is going to be its own separate entity when uploaded online. So I am going to be introducing myself and the product 4 times during this presentation. We are going to ask you to save questions to the end of each presentation, but we do value your input and your questions. So please write them down. Please ask them at the end of each presentation. I may or may not be able to answer them for you. If I can't, I will get back to you and let you know the answers to your questions. So to start out, the first presentation that we are going to be giving is repair of the mini stirrer. So this is the mini stirrer repair training. My name is Nathaniel Pfeifert. I am a product design engineer. And the purpose of this is just to familiarize you with the disassembly, repair, and calibration of these mini stirrer units, this whole product line. Before we start, we should go through a few safety precautions. So the main thing here is refer to your full service manual for all the safety precautions. I'm only going to hit a few different bullet points here. The first thing is to only connect to a power supply via the properly rated grounded electrical outlet. So make sure you're not plugging in a 120 unit to a 230 volt source. Make sure that your rating is correct. And particularly on this unit, we are going to be using a power supply that doesn't fluctuate. So we're going to be using a voltage generator, and that's going to be very important for your calibration and getting a good quality calibration. Repair only in a safe, dry, indoor laboratory condition on a suitable, clean, sturdy surface. For this particular unit, it doesn't have to be as sturdy as some of the other units that we're going through, but you do want to be working on a laboratory quality table in clean conditions. The O-House white background on these does get dirty very quickly, so we're going to be using gloves like you see me wearing now, and other precautions to keep this unit clean, ESD safe, which is the next thing on my list. Use ESD protection whenever you're working with electronics on these units. It's very important that no circuit board, no electronics gets exposed to ESD, because you may not be able to pick up the causes until this gets back to a customer. So it could cause a latent failure if you do not use that. This is what we're going to be using today. It's a grounded ESD strap that goes onto the wrist, and this clips onto a grounded surface. And in that way, we won't be compromising any of the electronics. For heating units, this is a stirrer presentation, but for the heater units, do not operate at max temp without a beaker or flask. Don't even go close to the maximum temperature without a beaker or flask on top, filled with a suitable liquid, and this needs to be placed on the top plate. Don't let the fluid boil off. This particular one is a very specific volume for speed calibration. So it's very important that you don't let any of it boil away. We will be doing the speed calibration and not testing heater units today. So that's not going to be an issue in this situation, but also make sure that when you're using a heating unit, you don't get it close to something that could burn or create a fire hazard. Always use caution when heating volatile materials. So if you have an oil that can get up to a fairly high temperature, that's great. Make sure that no water gets into that oil, or you could have boiling issues where the water boils before the oil does and pops and sprays oil around the room, which is quite an issue. When we're working, we also always use eye protection. A very important thing during repair. So to familiarize you with this unit, this is an analog unit. Here you have the heat on, off, and control knob, and the stir on, off, and control knob. With stir, you can hear a definite click between the on and off, and then a linear scale. Now, on the analog units, this linear scale, it does not mean that you're necessarily going to get a linear output from that scale. So it's important that as you turn it on, we're only really calibrating this at low speed, and we are testing at low speed, mid speed, and high speed.
Yeah, I have one.
You do have, for heating units, you have a power switch in back here, and that's either on or off. Let's get close. Circle is off, and the eye is on. The other thing as you're doing this is, as you continue to turn the speed up, sometimes when set at 1, the unit does not go on right away. This is a very common issue with analog speed, and for this particular unit that is acceptable. In the manual, if it doesn't overcome the friction of whatever liquid you're using, you simply turn it up a little bit until it starts to stir, and then turn it back down to the speed that you want it to go at. Okay, so as we are troubleshooting, the main thing we're looking at is calibration if the unit will not reach the desired speed. So the unit is running either too fast or too slow. That could be because you have too high a volume of liquid or too viscous a liquid for the unit to push. It could be that a customer has the speed set at too low a speed and maybe needs to jump start it, like I just talked about. But if you're getting it back, it probably means that the user has gone through all these things, and the unit needs a calibration. Before you get into the calibration, it's good to test it out and make sure that you can can or can't overcome the friction with an acceptable liquid. Today we're using water, proper stir bar, and overcome it by turning up the speed a little bit. If we do need to go into a calibration, that's what we're going to be dealing with in this training. So some of the tools you're going to need, we already talked about the wrist strap, 4-pound manual torque driver. Today we're going to represent that with some hand tools. We are not going to go into exact torques, but as you're putting this back together, it is very important to torque the unit to the correct amount. All our torques that we do here at this facility are in English, but it's an easy conversion to metric torque as well. So we're going to use a 4 inch-pound manual torque driver generally for this unit. We do have an 11/32 nut driver that you will need for this unit. And we will also use a California Instruments tester. If I can bring this down. California Instruments tester to give the correct voltage.
I'm sorry, I'm laughing because I just saw Evan.
So we use the California Instruments tester to produce a stable 230 volt for this unit power source. For the calibration and testing, I've already shown the water with the stir bar. We will also need a trim pot tool. Bring this close and turn it so you can see the end. Get my face out of this. There we go. There we go. Trim pot tool, and this will help us calibrate the unit. We will also need a strobe tachometer, strobe or photo tachometer, and the stir bar in the water with the 250 milliliter flask. For testing only, we will need, for heating units, we'll need a temperature probe and a high pot insulation tester, the Megger 230315 high pot tester is what we use here. An equivalent high pot tester is acceptable as well. We won't be going through heat testing today, and we won't be going through high pot testing. You can refer to your repair manual for that. All right, now moving into the fun part, moving into disassembly of the unit. So there are 4 screws on the bottom of this that we're going to remove. Here, 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 and there. Those 4 screws out. This unit is a very easy assembly. It has very easy assembly and disassembly. As you're removing the screws on each of these units, so we have 4 plastite screws. They're going to be saved, so you can put each of those off to the side. When you open your high pot, when you open your 230 volt unit, sure this this is not. There is going to be, during the actual presentation, this will be together. 230-volt units have this Schaffner filter on the bottom, and we will be removing those, removing that, using your hex wrench. And taking off those 2 screws. Now the bottom housing can come completely off, and you have your nuts and screws, again, off to the side, saved for putting it back together. Now you have the unit open here. Did you get the, Evan, did you get the foam calibration
We're
thing?
talking about the phone thing. Yeah, we were talking, you had that. I'll grab that.
All right.
I'll get that.
So now for calibration, before we get to calibration, we're going to do a workmanship check. So we're going to look inside and make sure all the wires are routed correctly. Make sure they're wire tied, make sure nothing's rubbing, make sure all the connections are tight. And particularly what we're looking for is that no wires are going to be around the motor. So there's no danger of the wires being caught up in the motor. We're also going to look at the outside of the unit. Probably it's a good idea as you're repairing to take pictures before and after of the unit to make sure there are no scratches, dents, anything that could be an issue when you're sending this back to a customer. You want to document that before you open up the unit and before you start to repair the unit. All right, next we're going to move on to calibration. And here we're going to turn everything, start out with everything off, both heat and speed off. We're going to put the unit on the edge of the counter using these four bosses to support it, and so that we can get to the speed potentiometer here with the high pot tool. Oh, here we have a fixture that's also very useful. So here you have just a foam piece that helps lift this up. It's big enough for each of those bosses to sit on, lifts the unit up and away from the table, and it can really help you out with your calibration. So we're going to sit that right at the edge of the table. There we go. Sit the unit on top so that it's off the edge. And we're going to take the calibration tool. We'll take the calibration tool and eventually use that to change the pot settings. All right, right now we're going to get this powered up. Obviously, before you power it, you want to make sure that you're not reaching in and having any danger of getting electrocuted by a powered unit. So we're going to plug it in. I'm going to have, Andy, would you power up the source here? the 230-volt unit. All right. The other thing that the foam pad does is, as this is going, it makes sure that it does not vibrate off the table at all. Okay. So we're going to set the unit to maximum once Andy gets this on. And we're going to let it run for about 10 minutes. Now, I'm not going to do that for this presentation, but I will have it going. That's running without any load on it for 10 minutes. We've already had this unit burning in. You know, already had it running previously. So the motor is already warmed up for this presentation. But you want to turn it on. Turn it on to 10. Evan or Andy, seems to be going a lot further than the other one.
Than 10?
A lot further than 10, so it's down there.
Does it go, or you mean the knob?
Yeah, the knob.
The knob
Just-
goes over.
It can go
Yeah,
all the
the
way,
knob goes
almost
over
all the way
the
around.
knob, yeah.
Okay.
It's not
Does it go to one over?
So yeah, it goes to 1 all right. It turns off all right. So you're going to set it at 10.
Yeah, they change the front panel, so we're gonna go one way and people not running too fast, because the 230 volts, it'll decouple every time.
Okay. All right. So we've run it at 10, a speed of 10 for 10 minutes. We're now going to turn it off. We're going to take our sample with the stir bar inside. See that? Place it on top of the unit. And the stir bar really positions itself over the magnet. This is, again, 100 milliliters of water in a 250 milliliter flask. All right. Next, we're taking our high pot tool. We're going to go under the unit. I'm just going to move that off. Show you this. Very, very important. We are working with a live unit now. This is an insulated tool, but we don't want to go sticking it or sticking fingers anywhere where we could get electrocuted. Just want to come here right into that potentiometer as I showed you before, and then place this back down on the bench.
I think the tool should be able to stay there on its own.
No,
Not always.
not always. At least, you know, maybe some do.
Yeah, okay.
Maybe this side of it will.
Could also be
No.
installed.
Could be the specific potentiometer, or it could be the specific tool as well. But it won't stay there, unfortunately, on its own. But there we're up and into the potentiometer. The potentiometer is, it's quite sensitive. So you want to make sure at this point that you don't start turning it. Okay, so adjust the calibration. Okay, so now we're going to put the sample back on top. We took it off since I'm showing you. This is also best done at a higher position. So I'm actually going to get down low so that I can see under it, but you can really do this on a table that's eye level. And it's much easier to do. Okay. So we're going to adjust the potentiometer as you're looking up at it. Adjust it clockwise. So if you were to show you this, because it's in this position that we are adjusting it clockwise. It's gonna seem like it's counterclockwise when you have it down like this, but when you're looking down on the potentiometer, you're adjusting it all the way down counterclockwise. Is that correct, Devin, or do I need to switch this again?
I think I double checked, and the first switch we did was correct.
Okay. Okay. Now, we're going to turn this to 1. I'm going to turn it all the way counterclockwise. And we're going to raise the speed till the stir bar just gets going. Very small increments that you're using. As I said, this potentiometer is quite sensitive. And then we're going to turn it counterclockwise, turn down the speed. It stops, we just turn it up slightly until it starts spinning. Make sure the liquid is in the center. And then start to adjust it down. What you want to do is really get the stir bar as slow as possible, under 250 RPM, without the stir bar completely stopping. This might take several adjustments before you actually get it. That would be great if it'll keep spinning. You want to wait a while. Make sure that it spins correctly and does not stop at that 1 position. Make sure the dial is exactly on the 1. And then we're going to use our phototachometer. Take a speed. And when we use the phototachometer on this, it's actually capturing 2 cycles per rotation. So it's actually double what is, or sorry, it's half what is shown on the screen of the phototachometer.
So right off the phototachometer.
So this is around 250 RPM. So we are at about 125 RPM on the unit. That's great. What we're looking for is between 50 RPM and 250 RPM.
Wait, say it again. What was the range?
50 RPM and 250 RPM.
Did we say it was 150 to 350?
No, it's 150 plus minus 100.
150.
I just looked at the ECN
No.
before coming and changed
Yeah,
that.
well, like 150 plus minus 100.
So that's at position 1. All right, we're going to let that go, make sure that it does not stop. And we're going to turn the speed control up to position 5. What we're looking here, we're not looking to get a specific value. We are looking to make sure that the speed does indeed increase as we move to position 5. All right, then we're going to move it up to position 10. What we're looking for here is to make sure that the unit does not decouple. I'm going to bring you real close here. Going to, oh, maybe I can't. No, I'm not going to be able to do that.
Yeah.
All right. Is there any way we can zoom in on this?
No.
Okay, because there's no way that I can actually pick this up either and show. But you want to make sure that the stir bar does not decouple at max speed here, at speed 10.
We can show it once it's all closed up and try again.
To give you an idea of the speed, this is going right around 1500 RPM at the speed of 10. And we have control through the entire range. Okay, next we're going to lower the speed back to 5. Verify that the speed reduces, that we do have control through that range. Again, lower it back to 1. Make sure the stir bar does not stop. This is going well. We're going to completely turn off the unit. Unplug the unit, very important. Remove the sample. Flip the unit over, and we're going to reassemble.
I also want to turn off the switch. Take the off the on off
Oh,
switch in the back.
Yeah, so for your heating units, you're going to turn off the switch in back as well. Evan, can you take a note down to add that to the presentation? Somebody.
To take off the switch.
Yep. As you're reassembling, if it's a heating unit that has the switch, you want to make sure that it's aligned correctly in the back. On all units, you want to make sure that the wire routing is correct and cannot be pinched when the unit is put back together. So a nice, neat interior here is very important. All right. Next, we're going to put the filter back on. In the real presentation, these won't be together, so I won't have to take this time.
So,
Filter through. screws through. Put the nut on the opposite side. Probably easiest to do this one at a time. And it's also easiest not to tighten these down all the way until you have both of them in. Both nuts in place. Okay, here's where you are going to take your calibrated 4-inch-pound torque driver. And make sure they're torqued down. Then again, after you get that on, you're making sure all your wire routing is in place. Nothing can get pinched. Nothing is near the motor. Closing the unit up. Making sure your switch stays in the correct spot back here. Closing the unit up. So switch is correct. It's completely closed around the exterior, and you don't have any pinched wires on the inside. Once those three things are done, you can add your 4 plastite screws. Again, this is 4 inch-pounds of torque. And I'm doing these in diagonal pairs as I'm putting these back in. That's just a good practice for good quality tightening of screws. Not specifically for this unit, but for all the units that I do. So I tighten everything, and then I'm going to go back and torque them down in the pattern that I put them in at. And there you have the calibration of the mini stir. We're going to make sure that both knobs are completely down to the off position. Going to then test and pack. For the calibration unit, for the calibration of the unit, we've gone completely through that. For the testing of it, it's very similar to what we did for actually calibrating the unit. You're going to place the flask on top. Where did that get to? Yeah, it's over there. Place the flask on top, turn the speed bar until it starts moving. Lower the speed to 1, let run for 3 minutes. If the stir bar stops spinning, the unit needs to be recalibrated. This is just a second test after you have everything together. Again, on this unit, very, very small changes in voltage, changes in current can impact the calibration. So it's very important that you keep using the California tester to give it a consistent voltage and current. So what you're looking for is at slow speed, the stir bar is turning very, very slow, and at high speed, it does not decouple. If the bar decouples at any point, it has failed the test. Now, your final test check and packaging of the unit, you can go to the your service manual for, but we're going to, on every unit that we do, we're going to do a high pot test. We are going to do a visual check to make sure that it's dust-free, scratch-free, coming in at least as good as the customer returned it to us. And then we're going to pack the unit and ship it out. We are here to help. So if you have any questions, feel free to contact Mary. The address is in the presentation. She can put you in touch with the engineering team if need be. She can put you in touch with a specialist in the particular unit that you're looking at. Any unit that you have that has an issue, we're really looking to help you out with. Okay, before we end, are there any questions?
No question?
Thank you, and thank you for attending this mini stir O-House repair presentation.
So I would say give us 10 minutes and we'll come back to you.
Yeah, give us about 10 minutes and we'll come back to you with the next repair presentation for the next unit.
All right.